Here is also something that we did yesterday. We multiplied by a scale factor. So this part should be easy, and to make it even easier than easy, they changed it to be f of x equals x. This one's not 2x anymore, so let's change this to be just regular x. F of x equals x. What's the slope of the line? The number 1. Then it wants us to do g of x equals 3 f of x. So we'll delete the plus stuff, and we'll put 3 f of x, and that's going to give us g of x. Yeah, it said g. Since we talked about this yesterday, we'll just go through it quickly. It's not the y-intercept or the x-intercept that changed. If you have a graph that goes through the origin, then whenever we multiply by something right in front, the only thing it's going to do is change the slope. If you have a super basic equation like this one, and there's nothing adding or subtracting already, then whenever you do the scale factor to multiply, the only thing that's going to change is that the slope will be 3 times greater, or whatever number that is in front, that's how many times greater it's going to be. G of x is steeper than f of x by a factor of 3. Okay, so in these next examples, we're going to be keeping g of x, and we're just going to be changing what's in front of f of x, what the scale factor is. We're going to change the scale factor, and then we're going to see if there's a pattern. So I'll do D and E for you. D said 1/2. Notice in Desmos that you can do a fraction, and it's going to look like a fraction. G of x is 1/2 of f of x, and it's in the blue line. Also notice that you can click and turn on and off your line. So the blue one is is g of x. It's the new one that's half. It has a scale factor of 1/2. And if you zoom out, you can see that they're not parallel. And if you look in at a key point like 4 goes with 2 on the blue line, but 4 goes with 4 on the red line. So the slope is less steep. And then if we put the number 4 times x is going to make a slope of 4, and this one's going to be more steep. And so you can easily come up with a pattern whenever we multiply by a scale factor on the outside of the function. I had to make sure that you know that that's on the outside because in this next part... All right, let's do the last. Okay, it's not the last. Oh, it is the last. Did I skip something? No, we're just going fast because we're using a calculator today. Okay, let's do the last linear transformation. The last one is when you multiply, and you're multiplying inside of the parentheses. The difference is here, when we multiplied something, we multiplied it outside of the parentheses for the function. Well, now we're going to do it inside the parentheses and see what happens. We're going to keep the same f of x as just the parent function. The slope of the line is 1. And we're going to change h of x so that we have a parentheses, and inside the parentheses is 3 times x. So let's delete the scale factor outside, and let's put a 3 inside of the function's parentheses with x. We see that we're still going through the origin, and let's just get a look. What's a good point? Okay, 2 goes with 2 in the original. 2 goes with 6 in the new one. Okay, so let's put the original one that's going to go through each corner right there. And then the new graph is going to go with 2 with 6. 1, 2, 3, 4, 5, 6. Yes. And it's also going to go through the origin. Boom. Something like that. So obviously this app is not as good as OneNote, but this is what some of you have available to you, and that's why I'm showing it again today. Because you can easily open up a PDF into Microsoft Edge and then just start drawing. I'm using a stylus, so maybe I'm a little bit better than your finger, but this isn't great. But it's readable. And if you don't have a printer, but you do have a touchscreen, this could work for you. Okay, we graphed it. Now let's just see how things changed. The slope of the original one was 1. The slope of the new one, well, here's 2, 6, and here's a 0, 0. Let's do 6 minus 0 over 2 minus 0 to get 6 over 2, which is 3, and that was m equals 3. Is the new one steeper than or less steep than f of x? Obviously, it's steeper. H of x is steeper than f of x by a factor of 3. Do these functions. I think you guys understand how to do these right now, so I'll let you do these, and instead what I'm going to do is I'm going to do a more complicated one. So I'm going to do a, b, c, d, e, f, g, and I'll make h of x equal to, so I'll make a new function. I'll make k of x, and that one's going to be equal to 2x plus 4. And h of x will be equal to k of 1/2 x. Okay, so let me type in k of x into Desmos. Two x plus 4, right? Yes. And then h of x is going to equal k parentheses 1/2 x. And let's look at that. That's going to be the green one. And we can see that both of them have the same y-intercept. Both of these lines have the same y-intercept. Let me make one more change, and let's make a new function called we'll do j of x, and that one's going to equal a 1/2 on the outside times k of x. This purple line is like what we did yesterday. We multiplied by a scale factor to the entire function. The entire function k is 2x plus 4. When we multiply on the outside by 1/2, that's going to multiply the slope and the y-intercept by 1/2. And that's why on this purple line, the y-intercept is 2, whenever it started out as 4. And whatever the original slope is, now it's going to be half the slope on this purple line. On this green line, which is the one that actually has to do with this topic that y'all are doing, which is it's inside the parentheses, this green line, when you put the 1/2 inside of there, it doesn't change the y-intercept at all, and it only changes the slope. This green line is going to be half as steep as the red line. So if the red line for this new one that I just made was 2, then the slope of this one is going to be 1 because it's half. So this is less steep. Now let's talk about putting it all together on this last page of our notes. You do need to come up with your own conclusion right there after you fill in those 4 examples.